Hello everyone. Let us look in the next question in our projection of plane series. We have here a circular lamina of 50 diameter rests on HP such that one of its diameter is inclined at 30 degrees to VP and 45 degrees to HP. Draw its top and front views in this position. Now, as the people know, a circular lamina does not have any corners or edges. So that is why it has been mentioned here that one of its diameters is inclined at 30 degrees to VP and 45 degrees to HP, right? So let us look at the criteria which we are supposed to satisfy for this particular question. The first one is the shape. We have a circular lamina. Second one, diameter 50 diameter resting on HP. Then one of its diameter is inclined at 30 degrees to VP and 45 degrees to HP. Draw its top view and front view. So let us start off with the solution to this problem. We have here, the first step is to draw the XY line. So I have X, VP, HP and I have so this is the circular lamina of the 50 diameter. So it is a 25 radius. So I shall measure 25 in the compass. 25 in the compass. I shall measure and I shall draw a circle such that it is going to be resting on HP. So I have drawn the circle. Now it may be useful to know that it's better to divide the circle into 8 equal parts rather than 4 equal parts, which may not give you the appropriate final solution. Or if you try to increase the number of divisions into 12 or anything like that, it will be even more difficult to locate the points. So somewhere the 8 divisions are more optimized. So I shall draw the divisions over here. Then from the center 45 degrees and 45 degrees on the other side. So dividing this into 8 equal parts. So I have a circle whose radius happens to be 50 That also we can measure and we can show that also. Right? So let us name the points. These are not corners. I shall repeat, these are not corners, but these are ends of the diameter, the 8 diameters which we have drawn. So I have my point A, B, C, D, E, F, G and H. So I have my points up to H. So since we are placing this lamina flat on the horizontal plane, so from each of these points, let us draw the projection lines. B and C will be in the same straight line. A and E, yes, as you can see, they are in the same straight line. Then we have H and F, and finally we have our point G. So draw the projection line. We have drawn the projection lines. So let us get the front view for this. So I have my point over here. This is my C dash. This is my B dash bracket D dash. This is my A dash bracket E dash. This is my H dash bracket F dash. And finally I have my G dash. So we have satisfied everything with respect to the first position, that is the shape, dimension and resting on HP. Now let us look into the criteria which is supposed to satisfy. It is said that such that one of its diameter is inclined at 30 degrees to VP. That 30 degrees to VP, we shall look at it in the third position. At the same diameter is inclined at 45 degrees to HP. So the diameter which I can rotate is only from G to C. Right? So one of its diameter is inclined at 45 degrees to HP means I can rotate only G to C such that either of the point G dash is on the XY line and the point C is lifted, that is G dash to C dash will be inclined at an angle of 45 degrees, or if I rest it on C dash, then C dash to G dash will be inclined at an angle of 45 degrees. So I choose to rest it on G dash. If you choose to rest it on C dash, you are not wrong. Okay. So I'll locate an appropriate point. So G dash I have my point, and I shall locate the point to measure my 45 degrees. Next, I shall measure the distance from G dash to C dash now, which obviously is 50 mm. Measuring that distance, I shall cut the arc. So this happens to be my C dash. Next, G dash to B dash bracket D dash, I shall measure again and cut the arc. So that is same as C dash to H dash bracket F dash. So keeping it here, I shall cut the arc from the opposite end. And finally, I have C dash to A dash bracket E dash. C dash to A dash bracket E dash. So I have G dash over here. I have H dash bracket F dash. Then I have A dash bracket E dash. Then I have B dash bracket D dash. So join all these points with proper visible lines and we shall get our top view. The points for the top view. F and D will be in the same straight line, and at the same time H and B will be in a same straight line. And finally I have my point A. So my A and A dash are meeting here. This is my new A, B, C, D, E, F, G, and I have my H. So now when we draw this second position top view, we can draw it in the free hand, but kindly try to join it as appropriately as possible to draw our second position top view, the circle, which will look like an ellipse, which is an ellipse for us. So please do not draw it in a very haphazard manner. So try to join it in a single stroke. Okay, so let me also make an attempt. I'm not sure if I'll be able to get it right on the first go. So kindly please bear with me. So some of you may what you can do is you can draw first with a lightly you can draw, then you can darken it later to match the I think I've gotten it somewhere close. So let me finish it up with drawing with proper visible line, a dark visible line. I think if you are able to get so much, I think you're good enough, right? So our diameter over here is inclined at an angle of, yes, 45 degrees. So I think we've forgotten to draw this with a proper visible line. So let me draw it. So G dash to C dash drawn with a proper visible line. So we have completed our second position also, wherein it is resting on one of its diameters on HP, and that diameter has two points, that is G dash and C dash. So the point G dash is on the XY line. Now next step, the same diameter is inclined at 30 degrees to VP. Yes, this is very much another beat angle problem, because the beat angle has to be done wherein it is the medians, altitudes, diagonals, or the diameter in case of a circle is inclined an angle to VP. More precisely, it is actually the line which changes its edge length or length from the first position, second position. That is where you're supposed to be doing the beta angle. So more details a little later, maybe another video. So let us get into the solution of this problem. So as I told you, the same diameter G to C should be inclined at an angle of 45 degrees to HP, which is also inclined at 30 degrees to VP. So for our convenience sake, let me draw this as C1. So I'll take an appropriate point, and from there I shall draw a line inclined at an angle of 30 degrees to the XY line. So from, I'll take another point and I shall call that point as my G. This is my 30 degrees. Okay. So follow the same procedure which you've been following for the beta angle procedure, beta angle problems. So G to C I shall measure. And I'll cut an arc. So I've gotten my point C. Next I'll measure from G to C1. I shall measure. Oh, I'm sorry. You're supposed to draw a line which is passing through C and parallel to the XY line. So please draw that line. So after that, I've measured from G to C1, measuring it here. I'll cut the arc. I'll get my point C1. So draw this line from C1 to G and extrapolate it backwards. I'll get my beta angle. This is my beta angle. So measuring that beta angle value. So it says that here it is 44 degrees. So beta angle value may actually be 45 degrees on the dot, but when we are drawing it manually, plus or minus 1 degree or maybe 2 degrees can be acceptable, but not to a larger extent, right? So now let us recreate the second position top view in the third position top view, okay, such that my G to C1 is inclined at an angle of 44 degrees as per our beta angle solution, right? So measure from C1 to E. C1 to E will be the same as G to E, C1 to A, and G to A. So I shall locate all these, both these points. So I have my point, which is my point A, and I have my point E. Next, I shall measure from C1 to D next. I shall measure from C1 to D. That length is same as G to F. That length is same as G to H and C1 to B. So I shall locate that point. I shall cut the arcs for it. And finally, E to D. measure that distance. That will be the same as E to D is same as E to F, A to H and A to B. So keeping it here, I shall cut the arcs. So I have my point A, then I have my point B, C1, D, E, F, G and H. So again, this is another place wherein we are supposed to draw our ellipse. So we are recreating the second position top view and the third position top view, but inclined at this beta angle. So please draw it carefully, because this has to be done, or this can be done only through freehand procedure. So I'll draw a single light figure first. So after you have drawn it lightly, you see that your figure looks okay, like an acceptable ellipse. You can draw it with the proper visible line. Right? So we have drawn our third position top view. From here, let us draw the projection lines and get the front view for this. So from point A, point B, C1 or C, then I have from my point D, then I have from my point E, point F, G and H. Similarly, draw the projection lines from each of these points. I will not be drawing from G dash because it's along the XY line. So my A and A is here and A dash are meeting here. So this is my new A dash. B and B dash are meeting here. So this is my new B dash. C1 or C and C dash are meeting here. This is the new C dash. D and D dash are meeting here. This is my new D dash. E and E dash are meeting here. So this is my new E dash. F and F dash are meeting here. So this is my new F dash. G and G dash are meeting here. This is my new G dash. H and H dash are meeting here. This is my new H dash. So kindly please be very careful in locating these points. So since there are multiple points, there's every possibility of going wrong while locating the points. So it has happened multiple times. So just please be careful. Okay. So from here on, this position, this one is also drawn with the free hand. So after you draw it lightly, you draw it with the proper visible line. So there we go. So we have completed our third position front view. So here we are satisfied again. all the criteria, the same diameter which is inclined at 45 degrees to HP is also inclined at 30 degrees to VP, but it is a beta angle problem, right? Thank you for your time.